Now for this particular equation, we have the following. So copying down all of the given information, we have nitrogen reacting with acetylene to be able to form two molecules of hydrogen cyanide. Now for this particular chemical equation, our K sub C value at 300 degrees is also known. So we copy that one. K sub C is given to be 2.3 times 10 to the negative 4 at a temperature of 300 degrees Celsius. So with this particular equation already written down, the initial amounts of nitrogen and acetylene are also known. So initially, the initial concentration of nitrogen loaded into the reaction vessel is 2.2 mole per liter. Same with the initial concentration of acetylene, also known as well to us. So that is 1 mole per liter. Given all of this information, we are now being asked to find the concentrations of the product and the reactants at equilibrium. So to solve this one, we have the following. We have to first again look at the value of K sub C for us to know exactly what steps to take in order to solve this particular problem. Now we notice K sub C is rather small. Its value is 2.3 times 10 to the negative 4 at such a high temperature. So from what we already were able to discuss in our lectures, we know that when K sub C is very small, we are now able to use once again the small x approximation. Now luckily for us, the concentrations are already given in molars. Therefore, we could skip to writing the ice table for this one. So copying the balanced chemical equation for this, we now have nitrogen reacting with acetylene to form two molecules of hydrogen cyanide. Now initially, the concentrations of the reactants are already given. So we have 2.2 molars for nitrogen, and for acetylene, we are initially given 1 mole per liter of that one. Now as the reaction proceeds, some of the nitrogen, we call that as X, is being used up so that the amount of nitrogen decreases with time as our reaction is occurring. And same with our acetylene as well. Its amount is also decreasing by an amount X to be able to form 2x moles per liter of hydrogen cyanide. Now once equilibrium is achieved for this particular reaction at 300 degrees, the equilibrium concentrations should then be 2.2 minus X for nitrogen. For acetylene, that's 1 minus X. And for hydrogen cyanide, that would be 2X. Now that the ice table is already done, we are now ready to set up the K sub C expression for this particular reaction. So setting up the K sub C expression, we then write K sub C is equal to the concentration of hydrogen cyanide squared divided by the concentration of nitrogen multiplied by the concentration of our acetylene. Now plugging in the values in here, K sub C was given to us to be equal to 2.3 times 10 to the negative 4. We now write 2.3 times 10 to the negative 4 equal to, for hydrogen cyanide at equilibrium, that should then be 2x quantity squared divided by, for nitrogen, that's 2.2 minus x, and also for acetylene that would be 1 minus x. Now if you look closely at the right side of the equation, the right side is a rather complex rational expression. It would be quite a hassle to be able to simplify that and then solve for x, particularly if we are on a strict time limit. So since the value of our K sub C is a rather small value, we are now able to use our small x approximation to simplify matters. We simply have to assume that the x is so very small so that when you subtract the change in the concentration with the initial concentrations, it's just as if the equilibrium concentration is just the same as the initial concentration. So mathematically, we can express it as the following. So we can write, if we so choose, this assumption that the difference of 2.2 minus x is just about almost equal to 2.2, since x is really that small. Or alternatively, if you like, you can also use the assumption of 1 minus x. Either one should still give us the same answer in any case. Now, already assuming that the x is really that small, we can simplify the right hand side of this particular equation to give us the following. So 2.3 times 10 to the negative 4 should be approximately equal to the quantity 2x squared all over. For the denominator, the difference is just about equal to 2.2. And for our acetylene, the equilibrium concentration is very, very close to 1, since x is really that small. So simplifying this should give us, for the right hand side, that's 4x squared divided by 2.2. And multiplying now both sides of the equation by the denominator and dividing both sides by 4, we can now be able to solve for x squared. So x squared should be approximately equal to 2.3 times 10 to the negative 4 times 2.2 divided by 4. And to be able to solve for x, we also have to get the square root of both sides. So that x, plugging this into the calculator, should be approximately equal to 0.0112. Now we were able to get this value of x by using a simplifying assumption. Now this value of x is only as good as our assumption. If our assumption was not good in the first place, then the value of x that we got would not be as good as well. So we have to check the validity of the assumption that we've made. So to be able to check that assumption, we simply go back to the simplifying assumption that we have made and compute the percent error that we introduce into the computation by making this particular simplifying assumption. Now x we've already computed is equal to 0.0112 approximately. So we then write 0.0112 divided by the initial concentration of 2.2 times 100%. Now doing that and plugging it all into the calculator, we should be able to get the percent error for this one. So this is now going to introduce a percent error of 0.509%. Now with the percent error that small, we are confident that we have a very good value of approximation of x in our hands. So this value of x should then be very close to the actual value, and so our assumption here is a valid one to make. So with that already done, we can now confidently accept the value of x that we have, and we are now ready to solve for the equilibrium concentrations of our chemical species. For nitrogen, its equilibrium concentration is going to be approximately equal to 2.2 minus x. For acetylene, its equilibrium concentration is approximately equal to 1 minus x. And for hydrogen cyanide, that value should be just about equal to 2x. So plugging all of this into the calculator, using the value that we have gotten, using the approximation, these should then be equal to the following. So 2.2 moles per liter for nitrogen, 0.99 moles per liter for acetylene, and a concentration of 0.022 mole per liter for hydrogen cyanide.